Refractive Software is proud to introduce their latest product, Octane Render for 3D Max. Okay, let's talk a little bit about the hardware we're running on. We have a Core 2 Quad 2.6 GHz CPU. We have a single GTX 580 GPU for handling the display and the Octane Render. We're on a 64-bit build of Windows 7, and we have a 64-bit 3D Max 2012 edition. And what we have loaded here is a neat little Lego car, and it's about 1 million vertices, as you can see right there. And we have a simple studio setup. We have a plane for the ground and 2 planes we'll be using for our mesh emitters to light our scene. So let's set up the rendering. We'll hit the render setup. We'll go and assign the renderer right there. And then we'll choose the Octane 3D Max render from there. And what that will do is that will load all of the render settings that we have available to us in the Octane 3D Max plugin. It's important to note that this plugin is not a simplified version of Octane Render. Every setting that's available in Octane Render standalone is available inside the plugin. It's also important to note that this is not linked to some external program. It's not passing material back and forth through some type of pipeline or through some type of file transfer. It's directly integrated inside 3D Max's process space with direct memory access between Max and Octane. So that's very important. It's a truly integrated rendering plugin. So to take a look and actually start rendering, we can hit the Open Octane Render Viewport button, which is right here. And what that will do is begin transferring the geometry over to the video card and open up an interactive window, and that process in this build takes approximately 40 seconds, and that's due to the way that we had the geometry stored in the current engine. We are in the process of implementing a new version, and when that new version is implemented, that process will take less than a few seconds to 5 to 10 seconds. So greatly improved speed, and it will also add the ability to use instancing, which will help us with even more complex scenes. So the interactive viewport shows up, but it's black. We have no light, so let's change the environment light to white, and then everything shows up. As you can see, we have a nice ambient occlusion effect with just a white environment light, and we'll move this render window off to the side and notice that as soon as we start interacting with the scene, the live render preview updates immediately. So let's open up the material editor and start assigning some materials. As you can see, the material previews are currently black. That's something that we will fix in the later versions of this plugin. It's important to note too that we have access to convert automatically inside this plugin in the future all of Max internals, mental ray materials, or V-ray materials directly over to Octane Materials. So you don't have to worry about having to reset up all those hard to set up materials you've done in the past. And there are 3 basic materials in Octane. We have a diffuse material, a glossy material, and then we also have a specular material, which is glassy, and then we have a mixed material. So let's start working on our lights. To use an environment light, or any mesh as a light in Octane Render, we set it as a diffuse material. And when we set it as a diffuse material, we'll have access to an emission slot where we can assign a blackbody emitter as the emission source. And as we wait a few seconds, the render will update. And now we have that plane acting as a light. As you can see, it's way too powerful, so we're going to tone down the power there. And let's get rid of our environment light and turn that down to black so we have just our mesh emitting lights. So we have our first light, and you can change the temperature in degrees Kelvin, so you can set it to any accurate color temperatures you'd like or to taste. We can change the power and see that interactively with our render. So we'll do the same thing to the other light. So we'll get a 2-light setup. We'll add another diffuse material, and then also assign an emission spectra as a blackbody emitter. And we can adjust the temperature and the power, and now we have a nice interactive rendering setup with 2 studio lights looking at our nice little Lego car. Now the next thing we're going to want to look at is we're going to want to probably work on the floor. So let's move that out of the way. We can also turn it to path tracing, so instead of just direct lighting, which is more of a simple ambient occlusion type of lighting scenario that's available in many other renders, now we have fully interactive unbiased path tracing, which is still very responsive in the scene, so we can still see exactly what the renderer is looking like. And let's go ahead and start working on adding a material for the floor. And hold on a second. Okay, we're going to assign that as a glossy material, and then we're also going to change the diffuse to a texture, and we'll use an image texture, and we're going to use this wood plank here. And you see immediately we can see that the wood plank has been assigned to the texture. Adjust the gamma to 5 and get a nice rich color. So the floor tile looks great. It's a little big though, so we're going to have to adjust the scale. As you can see, our car doesn't look quite to the right size there, so we can zoom back and take a look at it and adjust this to 10 by 5. And now it looks a lot more correct for the scale of the little Lego car, which looks good. And we can put it back onto direct lighting to have some more interactive rendering. And from here, I'm going to pause the render. We'll assign the rest of the materials to the car, and then we'll continue on showing some other material editing tricks. Okay, all the materials have been assigned, and now we're going to zoom into this tire, and we're going to show a neat feature that we've just added, which is subsurface light scattering. So to do that, we can use either a diffuse or a specular material. So we're going to choose a specular material, and we're going to adjust a scattering medium instead of an absorbing medium. So we'll click there. And now this will add the subsurface light scattering, and we can adjust that. Now the specular material begins to be truly clear, and we can adjust what type of absorption color we want. And it looks clear until we start playing with the scale here, and we're going to adjust the scale, and then you should be able to see the scattering effect take effect. And let's zoom in so we can take a little closer look at this wheel here. So we'll zoom in. And also, like, you can see the real-time depth of field in the Octane Render engine kicking in, and we're focusing here on this wheel, and you can just see the light penetrating that plastic, and you get that really nice subsurface light scattering effect. So that works out really nice. And so because we're actually running a true subsurface light scattering inside the render engine, that calculation is a little slow, and it's actually it takes up a lot of processing space. So it does take a lot longer for the render to clean up when you're using the subsurface light scattering, but depending on your model or the materials that you're using, that might be necessary to get the greatest realism, whether you're working on certain types of stone, porcelain, certain plastics, skin, depending on what you have. I mean, to have that effect available to you at a much accelerated rate compared with other rendering engines is pretty cool. So as you can see here, as we change the different settings, you can actually just watch the light penetrate and get deeper through that material, which is pretty neat. So again, still adds a great degree of interactivity with your render. You'll be able to set it to the parameters and get to exactly what you're looking for in your scene before you move on and let it settle and let the light penetrate deep into the material and get that nice effect. Okay, let's add some more lights to the scene. Let's go ahead and add a sunlight. So we can add that. And as you can see, as we move the light over here, as we move it, we get interactivity with inside our scene. So you can, takes the guesswork out of trying to figure out where exactly to put it. You can take a look at your scene and watch the shadows change and place them exactly where you want for your scene. So again, allows a great flexibility to use not only mesh emitters or HDR environments, or also be able to have control directly over a sunlight system. Change the exposure if we're a little too high there. And so that allows us even more flexibility over lighting our scene and having good interactivity to make sure that we've explored it and put the shadows and the lighting exactly how we like to. It reminds me of being almost like a real-time photographer, instead of having to bounce back and forth between waiting for a render result and moving things around. It allows you to have that freedom to be creative again while you're rendering and being able to explore your scene in ways that were not possible a short time ago. Now we're setting our scene up finally setting up for an animation. So we can set up all of our final materials, set up all our lighting, and when we're ready, we can actually start keyframing some things and start setting this up for an animation. Now it's important to note that anything that we can animate in 3D Max, we can animate and have in Octane Render. So if we would like to animate the lights, or animate the car, or animate other objects, we can do that real time. So to set up for our final render for doing this, I'm going to turn the samples down to 256 because that was just a little too many samples for a little preview animation. So we can go through and maybe change some other things, like change the aperture of the camera, to change the depth of field. We could change the exposure, set that up for our final render. We can then also go over and change and add some vignetting. Anything that you want, you can set up with inside the interactive render engine and set it up for a final animation. So we'll start putting in some keyframes of our lights and animate our sunlight so we can get it like a sun setting type of animation here, just to move the light. As you can see that as we step through the keyframes, the interactive render preview shows that that's changing as we step through keyframes. Now we're going to add a sphere, and it's going to translate over into the video card. So again, this process takes about 40 seconds under the current alpha build, but by the time we get to the next build, we should be on the new geometry instancing engine, which will allow that to happen much faster. And so now we have the sphere is inside the GPU memory and interacting in the scene, and as we change the key settings for that light, we'll see the shadow change. As the sun is moving, you can see that shadow change there. So we've got a little simple animated scene set up so that we can see, and we can keyframe objects moving and such. So all of that will happen with inside the render. Now it's important to note that Octane is a integrated render engine inside 3D Max. So that allows us to actually be inside the 3D Max rendering engine. You can use all of the integrated parts of Max as far as batch rendering, control view via the network queue software. All of this can happen inside 3D Max, but using the Octane render engine. So you're not limited to just using that interactive 3D preview render, but we actually also have the ability to be integrated directly into the rendering pipeline in Max. And again, right now that takes approximately 40 seconds of the 45 seconds to render a single frame for it to translate the geometry over to the video card. And in the future versions, that will be much shorter time per frame. But this allows you to see that we can use the internal 3D Max rendering pipeline to render using Octane Render. So thanks for checking out this video and getting an idea of our latest product. And you can head on over to refractivesoftware.com to learn more. Thanks for watching.